To monitor the variable data, such as critical quality characteristics of a process, like length, thickness, diameter, or strength, the two most common charts employed are the X-bar and R charts. These charts are always monitored simultaneously because they track two different, yet equally critical process parameters, the central tendency and the spread. The theoretical foundation of the X-bar chart is the Central Limit Theorem. This theorem states that as the number of samples increases, the sampling distribution of the sample means follows a normal curve, regardless the distribution of the population. This is why the X-bar chart requires the subgrouping of the samples, which involves collecting a set of individual observations under identical process conditions. When the population standard deviation is historically known, the upper and lower control limits for the X-bar chart are calculated using the following formula, where X double bar is the grand mean, Z is the critical value, which is typically set to 3, and N is the subgroup size. However, the true population standard deviation is often unknown or difficult to obtain in a real-world setting, therefore, control limits are calculated using the average range values. The specific distance of these limits from the center line is determined by the A2 factor, which is obtained from the control chart factor table based on the subgroup size used for each sample. While the X-bar chart monitors the process average, the R chart is used simultaneously to monitor the process dispersion or variability. The X-bar chart signals a shift in the process average, while the R chart tracks the consistency within the process. It is possible for the process average to remain well within the control limits even while the variation increases. This is why both charts are monitored simultaneously. To determine if the variability is stable, the control limits for the range chart are calculated using the following formulas, where R bar is the average range and D3 and D4 are the control chart factors designed to set the limits at 3 sigma. The control chart factor table provides specific numerical values for constants such as A2, D3, and D4, which are determined by the subgroup size N. These values replaces the complex standard deviation formulas with simple multiplication.